All right, in this video we're going to be looking at simplifying radical expressions. We'll also be doing multiplication and division. So what we're seeing here is, or what we're doing here is basically looking at how do we work with radicals? How are they simplified? How do we multiply them? How do we divide them? Later on we'll look at adding and subtracting radicals and solving radical equations. So we're just building a foundation here. So it says here for multiplication, the square root of a times the square root of b is equal to the square root of a times b. Now this really just comes down to a property of exponents. We know the square root of a can be written as a to the 1/2, and the square root of b can be written as b to the 1/2 power. And there's a property of exponents that allows us to do this. Usually what we do is we'll start with this and we'll get the other, but we're doing that in reverse. But these are equal, and of course this can be written as the square root of AB. And so we can use properties of exponents to prove these are true. In general, we're going to use this property. So basically what we're saying here is as long as the roots are the same, we can multiply the radicands, or what's inside the radical. So on number 1, we have the square root of 3 times the square root of 5. That's just going to equal the square root of 15. On number 2, when we multiply the 2 and 7x, we're going to end up with here cube root of 14x. And on number 3, we're just going to multiply our fractions just like we normally would. 5 over a times b over 2. We'll multiply across, and we get the square root of 5b over 2a. All right, let's move on. So let's talk about simplifying radicals. It says a square root is not considered to be simplified if its radicand has perfect square factors other than 1. So if you look at square root of 12, for example, this is not a simplified radical because 4 is a perfect square factor of 12. So it's important that we know what our perfect square factors are. We'll look at that in a second. But the other thing I want to mention here is I could easily change this to a cube root is not considered to be simplified if its radicand has perfect cube factors. And in fact, we can do fourth roots and fifth roots in the same way. Our focus will mainly be on square roots, but we will also look at cube roots, and you can see it works very similar. So first of all, we need to know what our perfect square factors other than 1 are. Of course, 1 squared is 1, and so 1 is a perfect square, but it's not going to help us when we simplify. So here's our perfect square factors. Notice I have from 4, which is 2 squared, all the way up to 144, which is 12 squared. And so if any of these numbers are factors or divisors of our radicand, then we're going to have to do some work to simplify the radical. So on number 4 here, on the square root of 12, we know that 4 is a factor, so we can actually write 12, or square root of 12, as the square root of 4 times the square root of 3. In fact, remember, if we multiply the square root of 4 times the square root of 3, we get 12. So we're basically going in the opposite direction. I call it breaking it down into two radicals that multiply to the same thing, but one of them is a perfect square, or the square root of a perfect square, and we can simplify that. Of course, here the square root of 4 is 2, and so we get 2 square root of 3, or 2 square roots of 3. All right, so if you think you got it, you might want to try and do at least up to 7, and if you are confident there, you can go all the way to 9, and then watch the video. All right, so on number 5, you can, if you look, 4 doesn't divide into 50, 9 doesn't, 16 doesn't, but notice 25 does. That is a perfect square factor, and we can write the square root of 50 as the square root of 25 times the square root of 2. And so we get 5 square roots of 2. Now I want to mention here something that I've seen quite frequently. Be careful if you're just doing this in your head, because a lot of times students will give me an answer of 2 times the square root of 5. They get things turned around. So at least in the beginning, it's really good, write your perfect square factor first, and then the other, what I call the leftover factor, second. And if you're consistent that way, you should get right answers. Of course, square root of 25 is 5, so 5 is the one that doesn't have the radical symbol. All right, so let's move on and see how you did on 6. Of course, 9 is a perfect square factor of 54, and it would be 9 times 6. And so we can now write this as 3 square roots of 6. Now you got to be careful on number 7. What you may have done is used 4 and 12. The problem here is the square root of 12. Notice that 4 is a divisor of 12, or a factor of 12, which means 12, the square root of 12 is not simplified. And so when this happens, well, first of all, we can't use this. I mean, you could actually continue and break it down. What I like to do is just look for the next factor that's a perfect square. Of course, 9 doesn't work, but how about 16? We could write this as the square root of 16 times the square root of 3. Notice the square root of 3 is simplified. There are no perfect square factors of 3, and so we're good here. It's going to be 4 square roots of 3. All right, on number 8, now I labeled the perfect squares up above, but those were the numbers. If you think about it, x squared, x to the 4th, x to the 6th, x to the 8th, any even power of x would be a perfect square. For example, x to the 6th would be x cubed squared, or you could think of it as x cubed times x cubed. And so these are all considered perfect square factors. And so if you look at 8, we can see that n to the 3rd power is not a perfect square, but if you drop the degree 1, or if you go down to n squared, we could write this as the square root of n squared times the square root of n. And of course, the square root of n squared is n, and so we get n square root of n. All right, on number 9, I'm going to break this into my perfect square factors and my leftover factors. So for 24, 4 would be a perfect square factor. And so let's write the 4. And we know x to the 5th is not a perfect square factor. It's not even, an even power. But if we dropped 1 to x to the 4th, that would be a perfect square. And so now we want to write the leftover factors. 4 times 6 is 24, and x to the 4th times x would be x to the 5th. Now keep in mind, when we multiply these, we have to get what we started with. But the other thing is the first one is my perfect squares, and I'm going to be able to simplify that. The second radical is going to be the leftover factors. Notice there are no more perfect square factors that I can factor out here. And so the square root of 4x to the 4th, well, square root of 4 is 2, and square root of x to the 4th is x squared. And then don't forget your leftover part, the square root of 6x. Now, what I've shown you here is probably, I would say it's the most sophisticated way and the quickest way to do these problems. But if you've never really learned this before, there's another way, or I should say if you're having a hard time seeing this and you're just not seeing the numbers well, there's another way that works really, really great. And it's where we break our radicand into its prime factors. So let's look at number 4, and I'll show you how I use this other technique where we use the prime factors. So we can write 12. Well, let's look at the 12. We can do what's called a little factor tree. And when you do this, you can look for any two numbers other than using 1. You don't want to use 1 when you break it down because that doesn't help. 12 times 1 doesn't break 12 down. So in this case, I would say, okay, let's do 2 and 6. If you did 3 and 4, that would still work. The 2 is a prime number. Remember, prime numbers are numbers that only have two factors, 1 and the number itself. In other words, the only way to get 2 is 2 times 1. So it's important that you know your prime numbers. You know, I didn't write them out earlier, but I'll go ahead and put them up here. 2, 3, 5, 7, whoops. Not 9, because 9 is divisible by 3. How about 11, 13, not 15. How about 17, 19? Those are the ones less than 20, and I think that'll get us through here. But all of these are numbers that have only 1 and the number itself as factors. All right, so 6 can be broken down into 2 times 3, and notice those are both prime. And so now I can write the square root of 12 as the square root of 2 times 2 times 3. Now, I'm going to tell you this way. A student told me this a long time ago, a way that their teacher had told them to help them remember. We're going to think as the radical symbol as the house. Or no, I'm sorry, as jail. So the radical symbol represents jail, and so these numbers are in jail. And the only way to get out of jail is to pair up with somebody. And so these guys are going to pair up. And so we can pull 1, 2 out. And so we end up with 2 times whatever's left inside, which in this case is just the 3. So we get 2 square roots of 3. Now, when you go for each pair, basically, you pull out 1 factor. So I don't know if one of the guys got shot or what happened, but you end up with 2 square roots of 3 here. But for each pair, you can pull out a factor. So that's how it works. Let's do a couple more like that. So we can, for square root of 54, we can break that down into 6 times 9. Neither of those are prime. And then 6 breaks into 2 times 3, and 9 breaks down to 3 times 3. So we can write the square root of 54 as the square root of 2 times 3 times 3 times 3. So 3 3s. Notice we have one pair, a pair of 3s, and so we can pull out a 3, and notice what's left inside the radical is 2 times 3, which is 6. Whatever's left over or whatever you pull out, whatever factors, you have to multiply those. Notice we got the same answer. Let's look at the square root of 50. When you break that one down, you would get 2 times 5 times 5, and so we can pull out a 5 here. All right, and this works really nice on a problem like number 7. So with 48, you can break that down into 6 times 8. Of course, 6 is 2 times 3, and those are both prime. 8 is 2 times 4, the 2's prime, and we can break the 4 into 2 more prime factors of 2. And so when we write it in its factored form, notice we have 4 2's, the square root of 4 2's multiplied times 3. So we have 2 pairs. We have 2 pairs of 2, so we can pull out 2 factors of 2. So out front we'll have 2 times 2, which is 4. Well, we can go ahead and write it at the end here. So it would be 4 square roots of 3. Notice the only thing that we had left over in jail was the 3. All right, so you might want to see if you can do number 8 and 9 that way, if you like that technique, or otherwise you can just move on to the next slide. All right, so if you did 8, you can break n cubed down into 3 factors of n. We have 1 pair, so we can pull out 1 factor of n. On number 9, we have 24x to the 5th, and we can break 24 down into 3 times 8. Now again, if you use 4 times 6, that'll work too. In the end, you'll end up with the same prime factors. So here 3 is prime, and 8 breaks down into 4 times 2. 2 is prime. We can break the 4 down into 2 more prime factors of 2. And so when we prime factor 24x to the 5th, we're going to have 3 2's multiplied times 3 times 5 x's. And so we're looking for pairs since this is square roots. We've got a pair of 2's and 2 pairs of x. And so we can pull out a 2 and 2 factors of x, so x times x. That's going to be 2x squared. And notice what's left inside, 2 times 3 times x. So it'll be 2x squared times the square root of 6x. All right, so this is a way that, so you have 2 methods you can use to simplify radicals, and really it's whichever you prefer. But you can see the first way I showed you goes a little bit quicker, but that's only if you can see the numbers that you need. I know sometimes I'll see students do, like they'll break 12 into 2 times 6. Well, that doesn't do us any good because neither of those are perfect squares. And so you wouldn't do that. When we did square root of 12, we used the 4 because 4 is the perfect square factor. So when you break the radical down, the first radical, you're going to put in all your perfect squares, and the leftovers go under the other radical. All right, let's move on. All right, so these are a little more challenging, so you might try using either technique, and then and now be careful when you do number 11, because now you're working with the cube root. So you may want to wait on me for that one, or if you want to give it a shot and see what you come up with and then watch the video, then I would do that. All right, so let's go ahead and see how you did here. So on number 10, so I see 75 there, and I know 25 is a perfect square factor, and x squared is a perfect square factor, and y cubed's not, but y squared would be. My leftover factors, well, let's see, 3 times 25 is the 75, and I also need a factor of y. And so the square root of 25x squared y squared is 5xy, and then I've got times the square root of 3y. Now if you prime factor 75, that's 3 times 25, the 3 is prime, and if you break that 25 down, you get 5 times 5. And so we can break the square root of 75x squared y cubed into 3 times 5 times 5 times 2 x's times 3 y's. And so you can see we have a pair of x's, I'm sorry, a pair of 5's, a pair of x's, and a pair of y's. So I can pull out a factor of 5x and y. We get 5xy. And then notice what's left over inside. We still have 3 times y. So times the square root of 3y, and so that's our answer. So you see we get the same thing. Now, when you look at number 11, since we're dealing with cube roots, if we're going to break this down, it doesn't help us to deal with perfect squares. We want to deal with perfect cubes. Numbers like 1, although actually 1 doesn't help us. It's got to be a number other than 1. So 2 cubed is 8. 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. And you can see it's the 8 that is a factor of 16 here. So I could actually write this as the cube root of 8 times the cube root of 2. Notice when you multiply those, you do get what you started with. But the cube root of 8, well, we know 2 cubed would be 8, so the cube root of 8 is 2. And then don't forget to write cube root of 2. So 2 times the cube root of 2. Now if you did it in prime by doing the prime factors, you would write the cube root of 16. I'm not going to do the prime factorization for you, but you can break it down. I guess I did do it. You get 4 2's when you do that. And so it's the cube root of 4 2's. And now this time, in order to get out of jail, you don't need 2 guys, you're going to need 3. And so notice I have a triple of 2's, and so I can pull out one factor of 2, and it'll be times the cube root of whatever's left, which in this case is just the 2. And so you see we get the same answer. So whichever way you prefer, I would encourage you to try number 12. All right, so let's, again, hopefully you stopped the video, you figured it out, and now I'm just going to tell you how smart you are. So let's see how you did. So I can break this down into the cube root of, let's see, my perfect cube of 250. Notice that half of that is 125, so it'd be 125. And then x to the 5th is not a perfect cube, but think about what our perfect cubes would be. X cubed, x to the 6th, x to the 9th, right? Because you could write x to the 6th as x squared cubed, and you could write x to the 9th as x cubed cubed. And so in our problem, we would include x cubed. In fact, we know that if you take the cube root of x cubed, you just get x. All right, so what's our leftover factor? Well, the cube root of, well, let's see, 2 times 125 would be the 250, and then x cubed times x squared would be x to the 5th. And so the cube root of 125x cubed is going to be 5x, and then you have the leftover part, which is the cube root of 2x squared. Now if you do it using prime factors, 250, well, let's see, that's 25 times 10. And again, you may have broken it down a different way, but you should end up with the same prime factors. So 5 times 5 is what you get when you break down 25, and 10 breaks down into 2 times 5, all prime factors. And so we can write this as the cube root of 2 times 5 times 5 times 5, so 3 5s, times 5x's multiplied. So write out your 5x's. You can see we have 3 5s and 3 x's, so 2 triples here. So I can pull out a factor of 5 and x. Now what's left over inside? I have 2 times x, so it'll be times the cube root of 2x squared. And again, you can see I got the same answer as before. I'm going to go ahead and stop the video here, and I'll do a second video to finish things out where we'll be looking at division.